Solving exponential equations and inequalities. There's two different cases. The first case is when we have that our bases are alike, like in this case, 3 and 3. Anytime that they are the same, all you have to do is bring down their exponents and set them equal to each other. This is why you see 2x minus 2 is equal to 6, and then you will solve for x, like whenever you solve for a variable. So you add the 2, and that's how we get 6 plus 2 is 8. Divide by 2, and that's how we get that x is equal to 4. Now in the second case, if the bases are different, we need to rewrite each side with a common base. In this case, we had a 3 and a 1/9. Now remember, you get a 9 as 3 squared, but anytime it's a fraction, your exponent will have to be negative. So we rewrite 1/9 as 3 to the negative second power. Since our bases are alike now we set our exponents equal to each other. 2x minus 2 is equal to negative 2. We add 2 to both sides. We have 2x is equal to 0. 0 divided by 2 would be 0. This is why x is still 0. Now let's try some problems. Let's look at the first one here. And the first one is 5 raised to the power of x minus 7 equals to 5 squared. As we can see, both of our bases are the same. Since they're the same, all we have to do is rewrite the exponents. X minus 7 equals to 2. In order to solve for x, we will have to add 7 to both sides. The 7 on the left side of the equal sign will cancel, and 7 plus 2 is 9. So we figure out that x is equal to 9. Let's just check the work, and it's always safer to check. But we have 5 raised to the 9 minus 7 power should be equal to 5 to the second power. Now 9 minus 7 is 2, so of course 5 to the second is equal to 5 to the second. Moving on to the second problem. If we see our bases are not the same. Now looking at the 2 and looking at the 8, they are both a base of 2. So 2 to the what power would give you 8? 2 times 2 is 4. 4 times 2 is 8. So that would mean that it is 2 to the third. Now this is the way we would rewrite them. So we check, hey, our bases are the same now. We could go ahead and bring down our exponents, set them equal to each other. Now we need to solve for x. We will need to add 4 to both sides. The 4's on the left side will cancel, so we end up with 3x is equal to 7. We need to solve for x, so we divide both sides by 3, and we find out that x is 7/3. We still need to check our work, so let's check it. 2 raised to the power of 3, replacing the x with 7/3 minus 4, should be equal to 2 to the third power. 3 times 7/3 is equal to 7. 7 minus 4 is 3. So that would give you 2 to the third is equal to 2 to the third. Now let's look at our third problem right there. Our bases, once again, are not the same. 4 and 16. Can we get a 16 by using the number 4? We sure can. It becomes 4 squared. Now notice that since 16 already had an exponent, we need to make sure we put a 2 and then parentheses with its original exponent. And the other side would stay the same. So the bases are the same. So now we could bring down our exponents. Now since we have a parentheses, we will have to distribute and solve. So 2 times 2 is 4. 2 times negative x is negative 2x. We need to solve for x. So the first thing that I'm going to do is move the negative 2x on the left side to the other side. So plus 2x plus 2x. The one on the left side of the equal sign will cancel. So we have 4 equals to 4x plus 8. Now in order to solve for x, we need to get rid of that 8. So we're going to have to subtract 8 from both sides. So the 8's on the right side cancel, and we have 4x is equal to -4. And of course, we need to solve for x by dividing by 4. And that gives us that x equals -1. Now we need to check our work. That would mean that 4 raised to the second power, parentheses 2 minus -1 should equal to 4 raised to the second power times -1 plus 8. Please remember that anytime you have a minus and a negative, it becomes a positive. So that would become 2 times 3. And on the other side, it would be -2 plus 8. And both of them would end up being to the 6th power. So once again, this one proves to be true also. Now let's look at number 4. Looking at number 4, we do have the same base. So all we have to do is bring down our exponents. We need to solve for x. So we, first of all, will subtract the 1x from the left side on both sides. And that would give us that the ones on the left side will cancel. So we have 1 equals to x plus 3. In order to solve for x, we need to get rid of that positive 3. So then we will subtract 3 from both sides. The 3's on the right side of the equal sign will cancel. So we have x is equal to a -2. Now we might want to check this. So we have 2 to the power of -2 plus 1 should be equal to 2 to the second power times -2 plus 3. -2 plus 1 is -1, and that would become -4 plus 3. And what is -4 plus 3? It sure is a -1, so it checks to be right. Looking at number 5, 81 and 27, those numbers are not the same base. So how can we find out what the base of 81 and 27 are? Well, we know 81 would be 9 times 9. 27 is 9 times 3, and 9s are multiples of 3. So is there any way we could use the base of 3? We sure can. 81 will become 3 to the 4th power, and 27 is 3 to the 3rd power. But remember, because there was an original exponent, we need to put it at the very end inside of parentheses. We go ahead and check same basis, so now we could bring down our exponents. Please remember, on the right side we need to distribute, so 3 times x is 3x, 3 times -1 is -3. If we want to solve for x, we would need to get rid of that -3 on the right side of the equal sign. We will have to add 3 to both sides, and that would give us 3x equal to 7. Now we need to divide both sides by the 3 in front of the x, so that gives us x is 7/3. We need to check our work, and we have 3 to the 4th, which was the original 81, is equal to 3 raised to the 3rd power, 7/3 minus 1. Now, as we distribute on the right side, 3 times 7/3 becomes 7, and 3 times a -1 becomes a -3. So what is 7 minus 3? It becomes 4. So then that checks off as 3 to the 4th power. Number 6. Now let's look at our bases. Are they the same? No, they're not. Now please remember what we said earlier. How would you get a 25 if we use the base of 5? Yes, you're right. It is 5 squared. But can we use 5 squared for 1 over 25? No, we said that it would have to be the negative exponent. So if 5 squared is 25, 5 to the negative squared, or the -2 power, would give you 1 over 25. So this is why we're using these. And if we check, that's already the same base, so that would allow us to bring down our exponents. The only thing we have to do here to solve for x is add 5 to both sides. As we add 5s, the 5s on the right side of the equal sign cancel, so we have x equals -2 plus 5, which is 3. Lastly, we need to check our work. So we have 5 to the -2nd power. It should be equal to 5 Since it was x, 3 minus 5. And of course, what is 3 minus 5? That is a -2. So 5 to -2 is equal to 5 to -2. Please check your work when you're doing your problems. Thank you.